With the attribute noise, we can take the noise values and either add it, or we can multiply against the current values along our points. Being that we have a value of 1 to start, I want to reduce that value from 1, so I'm going to pick the multiplicative option right here. Now, in order to visualize this, I'm not going to rely on the rasterize right here. I actually want to have control over exactly how this looks, and I'll show you why here in a second. But create a volume visualization node and set that right next to it. And then under the density field, let's specify density. Set the flag right there. At first, it's not going to like us because we need to feed it a volume. So go right there, and we're good to go. Now, on this attribute noise, we have the noise type and the amplitude and all that stuff. I actually want to start by going to the very bottom here and specifying a minimum value. If we look back to that thermal image reference, you notice how there's always a consistent heat going on. So I don't want there to ever not be a temperature value of 0. I want the minimum here to be 0.2. And now on this volume visualization node, let's take our density scale and bring it up slightly until we have the whole thing being shown like that. That way we kind of have a better idea of what the values are in relation to the minimum of 0.2. Okay, on this attribute noise, let's go up here to the noise type and start off with some of the larger, well, actually I'll start off with like the larger mid-sized shapes, which I noticed kind of had a cellular look to it. So I found that this whirly down here, whirly cellular F2, F1 seemed to be a pretty cool thing. Let's actually also remap this noise and set the minimum value here to 0. 0 is the minimum for the noise, maximum is 1. But again, we still have this overall minimum giving us a floor of 0.2. Next up, we want to alter this distribution. So this distribution relates to how much, or I guess how likely is something to get the minimum value, which is 0, or something towards the maximum value of 1. And what I found is that if we kind of duck in the middle here and we go like this, so we have basically everything generally more likely to be nothing or a value of 1, that seemed to create a bit of contrast, which I liked. So let's do something kind of like this, and that will create shapes which we can more clearly see. Next up, let's go to this element size and come up with a cool size for this. I think probably around maybe like 0.4, 0.6 or so might be a good size. Let's also go up here and check the animated box so that we can see this moving around over time. And that looks pretty good. It's moving a little bit fast from what I saw in the reference. So let's take this pulse duration down to, let's say, 3, so that it lasts longer. And then also, I'm going to bring up the element size is fine. I think that's cool. Okay, we have that. Let's go to our roughness here and turn that down. We want a very well-defined cellular shape, so the roughness isn't really going to help us in that. And then also this lacunarity is going to basically influence how much of the smaller details are allowed to happen. So I like having a lacunarity that's kind of close to the defaults. I maybe want to add just a little bit of extra detail by turning this up, and sometimes that works out nicely. And then also, let's take this element size down to, let's say, maybe 0.35, so that now we have something a bit like that. So I think this is going to work nicely as a base noise. That's going to give us those main kind of cellular shapes that you saw before. Now, one thing I also noticed looking at that reference is that there was another band of heat that was more general across the whole thing. It was at a larger scale, and it was also moving more quickly. So what we can also do here is layer on noises on top of each other. And actually, before I get too far, let's change that scale to be a little bit higher. Once I saw the reference, I was like, you know, it's actually a little bit of a different scale. Let's try maybe like 0.65. And that seemed to represent that a bit better. Let's also take this pulse duration up to, let's say, 6. I think maybe around 5 or 6, that was pretty close to what that actually was. We'll go with 5. Okay, now as I was saying, we want another noise to layer on top of this. So hold down Alt, drag out, that'll create a copy. Hold down Y, that'll cut that. And let's, first of all, name this to mid noise, and we'll say large fast noise. So we'll say mid slow noise, large fast noise. And then also, let's go up here to this mode and now add to what we currently have. So for this large fast noise, let's change type here to flow. And then again, we want this to be faster. So we'll set the pulse duration to, let's say, 1 now. And also, let's just play this and see what it looks like. I think that in general, we want it more likely that it's not going to add something, because right now it's adding too much everywhere. It's just kind of turning everything into a blob. So let's bring that up on the distribution over there, and then let's turn this down so that, again, it's less likely for it to pick a high value. We'll kind of even cut into it a bit like that. So that now it just kind of comes in there every once in a while. We can still see those mid shapes though, generally speaking, they're still there. And that looks a bit nicer. Also, let's take the pulse duration down to 0.25. Let's really make this faster. Okay, so I think that's looking nice. Let's take the element size perhaps a little bit smaller to 0.45 and see what that does. And I think 0.45 looks pretty nice, actually. We'll do that. Let's take the pulse duration up just a tad bit, try to dial this in, maybe like 0.3. Like that. And then also I'm going to turn up the roughness in this just to start introducing a little bit more detail and breakup in the shape. So a little bit more roughness, a little bit more lacunarity, and then also maybe turn up the octaves so that we have another layer going on. Maybe like around 4 for the octaves. Let's now turn down this pulse duration to, let's say, 0.5, or I guess turn it up. Roughness down to 0.5. Lacunarity maybe like 1.75. It's always just kind of something you have to mess around with until it looks good. And then let's also take our distribution and again just kind of bring this down a tad bit. We might need to fine tune all of this after we've cached it out, but I think in general this is looking pretty darn good. Speaking of cache, let's create a file cache node, and I'm going to say $hip geo /$os, that's the node name, $os dot $f4, that's the frame number with 4 paddings, .bgeo .sc. And let's save this out. Let's now call this cache our volume source, right there. And then we will cache this out. Okay, I like creating a file node like this, setting it over here. Let's call this our volume source read. And we'll copy this, paste relative reference. And now let's do a flipbook with our volume visualization over here to see what that gives us. All right, and as you can see, the pulse duration is actually much different than what we saw in the viewport. That's because our viewport is lagging behind. It's not playing at the correct speed. So it's always important to do a flipbook of your source before you move on for this exact reason. Let's go to our pulse duration. We'll turn that up on both of our noises, and hopefully that'll get us to about the right spot. Okay, and there you go. It's not a perfect match to the reference, but in general, the behavior is acting in a very similar way. We don't want to get the reference exactly, well, I mean, the closer the better. But as long as you get it generally behaving the way that you saw it, then that'll be great. In the next video, let's move on by jumping into DOPS.